Hi everyone, welcome to Module 16, Machine Learning. In this module, I'm going to walk you through how to use some coding to do some simple machine learning. Machine learning is important not only in data science but also in financial analysis. Machine learning is widely used in the financial industry, such as quantitative trading, robot advisor, risk management, and money laundering prevention. Daily life application includes spam filtering, friend recommendation on social media, medical diagnosis, face detection, and autonomous driving. In short, machine learning uses algorithms to help people make more accurate predictions and classifications, leading to a better decision outcome. The accuracy and quality of machine learning are related to the size of the dataset and how the algorithm is written. It explains why there is a strong demand for well-trained programmers and big data. Machine learning algorithms can roughly be divided into the following three categories: supervised learning, such as linear regression; unsupervised learning, such as k-means clustering; reinforcement learning, such as q-learning. Although machine learning can provide us with a model to make predictions, we should always bear in mind the potential problem of overfitting. It describes a model that fits very well against its training data during optimization, but its accuracy in predicting the future is far below its performance in its training data. Let's take an example of rolling a die. Assume that we roll a fair die 10 times and get the result of 1, 3, 5, 6, 2, 5, 6, 4, 4, 5. If we are asked the probability of getting a 6 in rolling the next die, our educated guess would be 16.7%. However, if we use this dataset to train our model will tell us that the probability is almost 100%, as 5 is followed by 6 for all the times in the dataset. This problem arises because our model incorrectly recognizes noises. 5 is followed by 6 as a pattern. So our model will predict a high chance of getting a 6 after a 5 appears. Having a large dataset can only alleviate this problem of overfitting but cannot completely solve the problem. If someone fails to recognize this problem and use a biased model to make an investment decision, the outcome could be disastrous. One way to deal with this problem is to split our dataset into training data and testing data. Our model is first trained on the training data to optimize the combination of variable combination and the value of parameters. Our model will then perform on the testing data to evaluate the accuracy of the prediction of our model on unseen data. If the model's performance in the testing data is not far below its performance in the training data, the model could be considered appropriate. Otherwise, we must revise our model. For our example of rolling a die, we can expect that the performance of our model in the training data would be bad. A common practice of waiting for the two datasets is to assign 80% of data for training data and 20% of data for testing data. We will train a model to predict the returns of Apple based on the returns of the S&P 500 index. The capital asset pricing model, CAPM, is written as returns Apple equal alpha plus beta returns market plus epsilon, whether alpha is Apple's monthly and normal returns, beta is Apple's beta, and epsilon is the randomness of Apple stock returns. The training process contains three main steps: data preprocessing, model fitting, and model evaluation. First, we want to get the data. We want to get the data from 2014 to 2022, and here we want to get the data of Apple and VOO, which is a S&P 500 ETF. And the data we get from Pandas data reader is daily. We can get monthly data by retrieving rows corresponding to each month's last day. First, we append a new column YM to only contain the year and month information. Then, we append a new column date to contain a copy of the index, which is the datetime object. And we group the data frame by ym and select the last element in the date of each group. Then we use the locate function to retrieve the rows of each month's end. And then we want to get the closed column only. Lastly, we use the %change function to convert monthly price to monthly return and drop the first row since there would be no data in this row. Now we want to prepare our weights for linear regression function. First, we import numpy, and then we're going to transform the data frame of VOO and Apple to array. Since only one column is passed to the array will return a horizontal array instead of a vertical array. And the linear regression model in scikit-learn requires the X array to be vertical. So we use the reshape function to change the shape of X. The mask1 here is a special rule of reshape function. If you just want to control the row only, you could import mask1 to the other position and reshape the function will then calculate the corresponding numbers of columns by itself. Then we want to do standardization. From sklearn, we import preprocessing. This code will standardize X, which means that the mean value is subtracted from X, and the resulting value is divided by standard deviation. Standardization will affect the intercept and coefficient values when we train the model, but will not affect the prediction accuracy. In this ordinary linear regression, a standardization procedure is not necessary. Then we want to split the dataset into a training set and a test set. So here we import train test split. Train test split is a function to split the whole data into two subsets. One is the training set and the other one is the testing set. Test size is used to control the size of the test set. Here, we specify it to be 0.2, meaning that 80% of the data will go to the training dataset and 20% will go to the test set. Random state is used for the random generator. For a fixed random state, and the training data set and test set composition are constant. The choice of the random set is arbitrary. The model fitted for different random state will be different. If the random state is not specified, the training set and test set composition will be inconsistent. Every time we run the code, we get a different training and test set. Then we try to fit our data to the linear regression model. Here, we import linear regression, and then we want to use the function to run our model. So here we type model fit xtrain and ytrain. So it will actually instance a linear regression model and fit the model using the training set we got before. Now we get it. Then we want to show the alpha and the beta of our model. And then we want to show the regression model. So here you can see that the alpha is 0.025 and beta is 0.058. And the following is the regression model. So now we want to visualize our regression result. Here we want to plot our data point in a scatter plot, and at the same time, we want to plot our regression line. So you run it, you should be able to see the scatter plot, which is our data point, and also the regression line, which help us to make the forecast. Lastly, we want to do model evaluation. Here we use the predict function to predict the value of y according to the x provided and the model fit. We predict the y value using the x value in the test set. Then we could compare the predicted y value with the true y value in the test set to judge the model efficiency. So here we want to use the R-square to assess the efficiency. The statistical score R-square, which could be calculated using the predicted y value and the true y value, and it could be used to rate the goodness of the model fit. R-square is between 0 and 1. It could be the percentage of the variation explained by the regression. Generally, the larger the R-square, the better the fitted model. And lastly, we want to display the R-square value. Now we can see that our R-square is 27%. It means that our model is able to explain 27% of the variation of Apple stock return based on the VOO stock return. Thank you for watching this module. If you want to know about whether you understand the coding in this module, you can try the following exercise. Thank you again for watching. Hope to see you in next module. Goodbye.